Dear students, this is Olga Savina, and this is our laboratory experiment determining an equilibrium constant. The principles of equilibrium are important for many areas, for biological, industrial, geological, agricultural chemistries. And I have posted some videos from Jove, and you can watch them and learn about applications of this principle. The purpose of the experiment, of our experiment, is to determine, to study the equilibrium system, the system between iron 3 plus ion and thiocyanate ion with the formation of colored complex iron thiocyanate 2 plus. We will study this system, and our goal is to determine the equilibrium constant. So let's recall the Le Chatelier's principle, which states that when a system in chemical equilibrium is disturbed by a change of temperature, pressure, or a concentration, the system shifts the equilibrium composition in a way that tends to co-interact this change of variable. And here we will be changing the concentration of our reagents and shift the equilibrium towards the product. When the reaction between iron 3 plus and thiocyanate ions in aqueous solutions, a solution comes to equilibrium, the system consists of the reactants and the product. And as you remember, the rate of the forward reaction is equal to the rate of the reverse reaction, and the system is at equilibrium. And the objective is to determine the equilibrium constant for this reaction, which can be defined as the concentration of the product over concentrations of the reactants. Our reactants are colorless, but the complex will be colored. And we can use a spectrophotometer to monitor the absorbance due to complex ion without interference of the reactants. And we will apply the Beer's law, in which absorbance is proportional to the concentration. So here is the Beer's law. A states for the absorbance, K is a constant, and C is a concentration. So let's discuss it a little bit. So to determine K, we must measure the absorbances of series of solutions with a known amount of colored complex. So that means we have to prepare some solutions and know their concentrations and measure the absorbance. And knowing measuring absorbance and knowing concentrations, we can calculate our K. How we can do that? We will use the limited quantities of iron in excess of thiocyanate ion. So in our reaction, all iron ions will be converted into colored complex. All of them will be converted. Since thiocyanate ions in excess, so the concentration of our complex will be equal to the concentration of iron ion. So this is how we will calculate our concentrations. And so as more reactant added, the more product will be formed. And so we will prepare a series of solutions with known concentrations of iron thiocyanate 2 plus in the way we discussed, and measure absorbance of our solutions at 450 nanometers. Then we will plot the absorbance on the vertical axis, and concentrations will be on the horizontal axis, and determine K from it using linear regression method. So we will build the graph, which will look like that. The straight line starts from the intercept, and our K, actually, it's a slope. We will use this method of linear regression and calculate our K. And our next step, but before we go to our next step, I'd like to show you that during we will be doing a lot of dilutions during this experiment. And I'd like to recall the rules, the formula, how we will do that. So let's say we have a solution, let's say 0.0025 molar solution of potassium thiocyanate. Big M stands for moles per liter. This is kind of stock solution. And we are asked to dilute it. We are asked to take 4 milliliters of this solution and dilute it to 100 milliliters. So, and the goal is to calculate the final concentration of the diluted solution. We will use this formula, M1 times V1 is equal M2 times V2. So M1 states for the initial concentration, 0.0025. V1 states for the volume that we will take to prepare our new solution. It is 4 milliliters. M2, our new solution, the concentration of our new solution, and 100 milliliters. This is the volume we prepare. So using this formula, we'll calculate the concentration, the final concentration of a diluted solution. And here is another example. You can review this examples and use this formula for your calculations. Okay, and now we will work on it. We will work on the procedure. You will have 5 large test tubes. You have to mark them and discard all solutions into a special waste container and know how to use the spectrophotometer. What is important? We will use 2 different solutions of potassium thiocyanate. One of them is 1 molar, another one is 0.0025 molar solution. We have to pay attention on that. And this is our first step. We have to determine K in Beer's law. That means we have to prepare 5 different solutions with known concentration of thiocyanate. So remember, potassium thiocyanate in excess. And so this table represents our dilutions. And let's just check this table. So for the first test tube, we have 5 test tubes. For the first test tube, we have to add 1 milliliter of diluted iron nitrate solution, 5 milliliters of thiocyanate, 1 molar thiocyanate solution, and 0.1 molar solution of nitric acid, 4 milliliters of 0.1 molar solution. It says diluted iron nitrate from step 1, which means we will have to prepare this solution using this step. We will transfer 4 milliliters of 0.0025 molar solution of iron nitrate to a 100 milliliter graduated cylinder and add water till the mark. That means it's gonna be our first step in preparation of diluted solution. How we can calculate the concentration of this solution. So we will take 4 milliliters. I think I over-reported this number 4 and just only 1 0, but let me correct it to avoid any problems. Just a second, because I don't like this 0. So that is fine. So 4 milliliters of this solution, and concentration of this solution is 0.0025 moles per liter. And we have to prepare 100 milliliters of this solution, right? And we have already calculated that it's gonna be this value, because it's the same. The solution is different. It was just an example. The concentration is what? 0.00010 moles per liter. That's our diluted solution with concentration 0.0001 moles per liter. This is our diluted solution. Then we have to take 1 milliliter of this solution, add it to the test tube, and then add 5 milliliters of potassium thiocyanate and 4 milliliters of nitric acid. The total volume V2 will be what? 10 mils, right? How can we calculate the concentration of iron 3 plus and consequently iron thiocyanate complex for the first test tube? Very, very simple. Again, M1 times V1 is equal M2 times V2. M1 is what? This one, 0.0001 moles per liter. V1, 1 milliliter, is equals M2 times what? Times 10. The total volume is 10. This is how we can calculate the concentration of prepared solutions. Okay, I went a little bit ahead, but I'd like to explain it this way. So we will prepare these solutions, taking all precautions to avoid any contaminations and so on. They will be prepared, and then our next step is to measure, to prepare another series of solution and measure everything at once. So we did this part to determine K small for the Beer's law. Now we will work on another part of our experiment, and we will be working on preparation of solutions to determine the equilibrium constant. So, and it's another table, and it tells us that we have to use 0.0025 molar solution of iron nitrate and the same concentration, the solution of potassium thiocyanate with the same concentration, and 0.1 molar solution of nitric acid. Let's check what's going to be the total volumes of our solutions. 7 milliliters. So we have to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 test tubes, right? So in first test tube, we have to add 1 milliliter of iron nitrate, in second one, 1, and so on, according to this table. So first, in the 7th, and so on. Let's consider sixth one. Sixth test tube, 1 milliliter of iron nitrate, 1 milliliter of potassium thiocyanate, and 5 milliliters of nitric acid, and so on. We will prepare all of them, okay, according to this table. And then we have to measure the absorbance of these solutions. So we will measure the absorbance of these solutions, and then measure the absorbance of these solutions and record our results. So now I'm switching to your calculations, and I'm switching to your post-lab questions. Okay, your first post-lab question is to complete the following table and calculate iron thiocyanate 2 plus concentration for each test tube and inserting the absorbance as a first step in determining K, small k. All concentrations are to be given in m, moles per liter. We're talking about our first table, right? When was it? Here we're talking about table 5.1. We prepared these solutions, right? And we even calculated the concentrations of our first solution, right? Over here. The concentration of iron 3 plus, which will be equal to the concentration of iron thiocyanate 2 plus ion. Okay? And it's gonna be what? Have we done it? No, we haven't. M2, we can do it. M2 is equal, this is for the first test tube, what? 0.0001 0.0001 moles per liter times 1.0 milliliter over 10 milliliters. So it's gonna be what? 0.00001 moles per liter. You can use another way to express it like 0.01 1.0 times 10 to the power 1, 2, 3, 4, 5, negative fifth. It's gonna be your first concentration. So here also, guys, I'd like to make some corrections to this because the volumes of solution is given like 1, 2, 3, 4, 5, and so on. It's not correct. I will use the volumetric pipette and actually will transfer 1.0, 2.0, 3.0, 4.0, 5.0, and so on. That means we are able to measure to the plus minus 0.1 milliliters. So that means we have to express the volumes using two significant figures. 1.0, two significant figures. That's critical for us, and this is the correction we have to make. Okay, let's return back to this table. We determined that first concentration is 1.0 times 10 to the power negative 50. Absorbance will be measured. And second, concentrations and so on will be calculated, and absorbance will be measured. That's it. And here again, I'm returning you to the calculations of iron thiocyanate 2 plus and referring you to this table 5.1 table, and I explain you how you have to do these calculations, and here is the results. I hope it is clear so far, because in this lab you have to do a lot of calculations and just do it step by step. Next, we have to use the available piece of graph paper, and it is given in your lab manual, and plot the absorbance and values of iron thiocyanate 2 plus. So here is our graph. Concentrations will be on the x-axis and absorbance on the y. You have to plot 1, 2, 3, 4, 5 exactly. You will have five measurements. And then your goal is to determine what? Determine K. You have to determine K. So how we can do that? You have to use appendix C and use the method of linear regressions. That means what? You have to write your data in a table. Concentrations, first column, your concentrations already calculated. This is your iron 2 plus iron. You have already done it. Absorbance is measured also. Now you have to multiply every value of concentration by absorbance for first, for second row, for third, and so on. And the results will be here. Okay, C times A. Here it's your concentration squared. You have to square your concentration. Very simple. And here is the sum of these numbers. Here is the sum of squared concentrations. And here is the formula of K. How we can do that? Divide this sum, C times K, this one, over this one, and determine K. Okay, I hope it's clear. We have done these types of experiments and calculations in Gen Chem 1 labs course, so that will be easier. That is our next step. Now we have to complete the following table, and all explanations are given on the left side. So we need to know starting concentrations of thiocyanate and iron 3+ ion. And we have to use table 5.2 and the following formula to calculate these concentrations. And do these calculations and fill out this table according to the calculations. Let's recall. So table 5.2. Let's do it for the test tube number 6 for the iron 3+. This is our table 5.2. And this is our test tube number 6. Let's do that. This is for iron 3+. What we will be doing? 1 milliliter of iron 3+ times concentration of our solution 0.0025 molar over the volume is what? 1257.0 milliliters. This is our first concentration. Let me see what I got for this one. So I got 3.6 times 10 to the negative 4th m. This is my first volume. Let's check with thiocyanate. It's the same. It should be the same. We have the same concentrations of these both, and we took also 1 milliliter and diluted to 7 milliliters. So that means for these two, for the first test tube, which is number 6, it's gonna be the same for both. But beginning from the test tube number 7, it's gonna be different because here you take 1, here you take 1.5, and that means first 6, 7, 8, 9, and all these test tubes and all these concentrations for iron will be the same, right? And so on. So you will do it very easily, not so hard. So here you will have your values 3.6 times 10 to the negative 4th, 3.6 times 10 to the negative 4th, and you will do the rest. Now we have to do calculations of iron thiocyanate 2+. And here we have to use this formula. A is equal K times C. This is why we needed the value of K, because we measured absorbance of solutions with unknown concentration of our complex. So how we can do that? K is already calculated. It should be here. K is known. You have already done it. A actually is known too because A will be measured. You will record these values. I'm not giving you this table in these slides, but you will have your values of A. So that means for the first concentration for the iron thiocyanate, so we know that A is equal to K times C, right? To calculate concentration, which is C, you have to divide A by K and record your result. And for the rest, the same. Okay, you will do that. Now, we're moving to the next column. Equilibrium for iron 3+. What's going to be here? Starting concentration of iron 3+ minus concentration of iron thiocyanate 2+. So that means you have to subtract from this number. So starting concentration minus concentration of complex iron thiocyanate 2+ ion and record your number. The same story with the thiocyanate ion. Starting concentration of thiocyanate, it will be calculated minus the concentration of iron thiocyanate, and so on for this, and this. Pay attention on your calculations, because you will work with small numbers and with exponents. So pay attention and review math if you need it. But it's not so hard, just tedious. So, and finally, you have to calculate K, the equilibrium constant. So what is the formula? This is your product, the concentration of your product, over concentration of your reactants at equilibrium. That means what? K is equal. Let me clean it. This number over this number and over this number. Okay? Maybe do it like that. Okay? K will be what? This over this and over this. That's gonna be your K. That's it. Okay? So you will determine K for every test tube. Okay, calculate it. And then your goal is to calculate mean value of K. You will do that. And finally, you have to calculate the standard deviation. Deviation for K. So here is the formula, and I recommend you to review Appendix A. But the formula for standard deviation is this one: square root of the sum of deviations from the mean squared over n minus 1. So we have 10 measurements. That means here it's going to be 10 minus 1, 9, right? And here it's going to be the deviations out of the mean for every particular measurement. So review Appendix A, and you will be able to determine everything. So, and finally, this is our last slide, and it's a very important correction that I'd like to bring to this lab. We assume that we measure volumes of our solutions to plus minus 0.1 milliliter, which means we have to write not 1 milliliter, but 1.0 milliliters, etc., 2.0 milliliters, etc. every time. That means we have to express all results for the small k, for the Beer's law, for the constant of equilibrium, and so on. All our results should have two significant figures. And these corrections I'm bringing, because without that, the data will be kind of confused, and we have to take care of these significant figures. They play a role, big role in this lab. Finally, so resources: Eben and Gammon, your lecture book, chapter 14, the lab manual, Appendix C in the lab manual, and also I'd like to add Appendix A, because you have to calculate standard deviation. And also you may watch Jove videos posted in this lab module. Thank you for watching, and should you have any questions, feel free to contact me.